Hello, good morning everyone. This is the landing page of our website. So here you can see we are providing with three options: log in as researcher, as policymaker, and as student. I'll take you forward by logging in as a researcher. So I'll first enter my predefined credentials, which I have already signed up. I'll select here researcher and I'll sign in. After signing in, we can create here new project. So I have named my project as Maharashtra Borewell Survey 2020 to 2024. I have given a short description about it. Next, I'll select the region and clicking next. Here we'll have to upload the data in CSV or Excel format, which will get processed. So here I am uploading a mock data as of now. Here you can see the preview of the mock data, all the parameters. Next, I'll click next. Here you can see what all things will be done with the provided data, that is data that has been validated, and the warnings that have been displayed using AI. That is 12 samples with missing depth, 5 outliners detected. All these things will be displayed. Quality score will also be provided. Next, here you can see what all indices you can calculate and on what standards do you wish to calculate those indices. Here I am selecting BIS IS India as my water quality standard. These are the indices that will be calculated, that is HPI, HEI, and all the below. Also the spatial analysis will be given, and also the hidden trends will also be analyzed in our website. Now I click on create project. Of the imported data is done. This is what you get to see on the researcher dashboard. You can see here the average HPI, highest metal, critical sites, and the monitoring status. Also, you can get a deep analytics of all the 15 sites that we had uploaded. Clicking on the bar graph, you can see all the parameters of the bar graph, that is HPI, HEI, CD, and PLI. Also, you can see here that is the metal concentration trends that has occurred on all the 15 slides that you can compare. Also, you can see here lead versus cadmium correlation. These are basically the hidden trends that we are showing in graphical format. These are the trends that cannot be easily detected from the graphical in the graphical form. So we are using high-end data analysis for this, that is regression, correlation, and giving the outcomes in a graphical format so that the researchers can get better understanding of the data and they can give us the much more better outcomes. This is the HPI trend and the prediction that is given by AI, whatever will be taking place in the future. Next, here you can see the average metal concentration profile. This is the average metal concentration profile. Next, I'll show you the AI insights that we will get on our website. That is cadmium. These are the key findings that we got. Cadmium shows the highest contamination impact, that is 7.96 standard limit. 7.96 times of the standard limits. Next is lead is the second major contributor with 5.6 exceedance. So these are the key findings that can be used by the researcher to actually find out something meaningful. Next is the predictive analysis. Here you can see what are all the future predictions, that is the metal correlations or the contamination trend or the predictive HPI or all those things. Also we are providing with the model confidence because this is the future that cannot be guaranteed. These are the hidden pattern discovered that are discovered by the AI, which are not visually directly visible. This is, for example, strong correlation detected between cadmium and mercury, suggesting common pollution source. Next, you can see metal impact ranking. This is the metal impact ranking in a graphical format. These are the AI recommendations that you can see. That is increase monitoring frequency in northern region or focus remediation efforts on cadmium and lead. Also, you can see the regression model details over here. Next, I'll show you the data table. That is, in brief, the sample ID, latitude, longitude, and all the things that we had uploaded, and the risk status adjacent to it, that is high risk, critical. So basically, it is showing critical for all the data set because it was a GPT generated mock data. If we took the actual data, we'll get here high risk, critical, normal, etc. Now, whatever the analysis has been done for the uploaded data, you can see it in a visual form on the India map. Here you can see that contamination heat map for Delhi industrial area. We have demonstrated. This is chromium. This is the high risk chromium, and this is the area which is low risk chromium content. Here you can see that the risk level distribution Delhi industrial area, that is medium risk, high risk, and the low risk. Also, you can change the elements according to this. The heat map will get updated real time. After all the analysis is done, we can export the final data in a form of CSV, PDF, or GeoJSON. We have four options in actually which data we wish to export. Here we have all samples, or severe risk only, or recent data analysis, or the executive summary. As of now, I'll show you maybe in GeoJSON how the data is exported. Here I will click export data. After exporting the data, this is how I'll get the data as you can see there. And we can use this data for further analysis and taking the further actions. Okay, so this is our AR/VR water source scanner app for the general public or the field researchers. Here I have entered my credentials and selected field researcher. Now I will log in. After login, we can start web AR. So basically, a user just needs to point in point at the water source, and if the geolocations are matched, we can see that the water is safe for drinking or no. As of now, we are just using a laptop camera, so we are using a bottle over here, but in actual they'll be scanning both the water sources, and once it is scanned, and
warning, high contamination levels
you can see
detected.
here
Do not
my
consume
location
this
did
water.
not match my location has actually matched with a point that was contaminated on the map. We will show you it on the map. Here you can see that the spot that was detected is this. You can see it is red because it's a high contamination water. So basically we should not be drinking that water, or the normal general public should not be drinking that water. This was one of our feature. Here you can see that the spot that was detected is this. You can see it is red because it's a high contamination water. So basically we should not be drinking that water, or the normal general public should not be drinking that water. This was one of our feature.